so this is how to multiply and divide radical expressions. So, multiplying radical expressions is actually really easy. A lot of you guys have already done that. As long as they have the same index, you just multiply together the stuff that's on the inside. Alright, so here, 5 times 25 is technically negative 125, but I like keeping them separate because I know that I'm going to be looking for groups of 3. So I'm going to keep the negative 5 from the top. Okay, so this negative 5 is this piece here. And then 25, I'm calling it 5 times 5. Now, 25 could also be negative 5 times negative 5, right? So, to get a group of 3, I went ahead and made those negative to match the negative that was there. And so now with a group of 3, I can go ahead and pull the negative 5 out there. And that's the simplified version. Now, like I said, the index has to match. So sometimes our index doesn't. So in this case, this one has an index of 2, and this one has an index of 3. And so they don't quite work together. And so in order to be able to combine them, let's go ahead and change this to a 9, actually. So in order to actually combine them, that 9 didn't stick there. Sorry. We're going to go ahead and write them as a, like an exponent. So this one would be 3 to the 1/2. This one would be 9 to the 1/3, right? Now 9 is a base of 3, isn't it? Like I could call 9 3 squared. And so if I want to go ahead and combine these, I can zoom in on this. Okay, this 3 would be to the 2/3 now. So I have 1/2 here and 2/3 here. And when you have the same base, you just add the exponents. So I'm just coming to the side here to do 1/2 plus 2/3. So I need to write these as 6's, right, to combine them. So 1/2 is 3/6, 2/3 is 4/6, so this would be 7/6. So there we go, we get 3 to the 7/6. Alright, so let's go ahead and let's try this a couple of times here. I think on these ones I kept all of the indices the same because I don't think that we really worry too much about when they have different a different index in this class. So we're going to multiply the numbers in front. So 2 times 3 gives me 6. I'm going to color code a little bit to help us here. So from the red, I have a 5, an X, and a Y. Maybe I should leave myself a little more room with those X's. Okay. Now from the blue, 40, right, is 5 times 8. 8 is 4 and 2. And 4 is 2 times 2. So from the 40, I have a 5, and I have 3 2's. I'm just kind of squishing in there. Also from the blue, I have 3 X's from the X cubed, and I have a Y. Now the index up here, this index is a 2, because it's the square root. So I'm looking for pairs that I could pull out. So I have a pair of 5s, a pair of 2's, a couple of X's, a couple of Y's. So when I'm simplifying here, I have a 5 and a 2, which is a 10. I took out 2 X's, so that would be an X squared, and I took out 1 Y. And so the only thing that's in this radical that I didn't circle is the 2 that's here. And my last step would just be to clean up this part where I multiply it together. So I have 60 X squared Y root 2. Let's do it again. All right, so again, I'm going to color code just for the sake of color coding. So these have the same index of 3, so we could just kind of go wild. So the 54 here, that's 2 and 27. And so when I decompose it, right, the red here gives me 2 times 3 times 3 times 3. I also have a pair of x's, and I have 3 y's. I'm just going to kind of pop the blue stuff in here next to all this. You're not really supposed to stack them. Like, they're not like a quotient. Like, this isn't a fraction. I just don't have enough room to squish everything, so I just kind of stack them up and call it good. It's more of a visual array as opposed to mathematically correct. Alright, so I have an index of 3, so I'm finding 3 of a kinds here. Alright, so it looks like I took a 3 out, I took an x out, and I took 2 sets of y out, so I'm going to call that y squared. And the stuff that's left in here, the 2 and 5 together make a 10. X and x makes x squared, and then I have the y. The same process works with division. Okay, now dividing is a little bit picky, okay? With dividing, I should have planned this a little bit better. We have to do something called rationalizing the denominator. Yeah, I haven't written out much notes on this part. That's okay. So, the first thing that you do is you cancel out what you can. Okay? So, in this case, I have 3 x's up here and 1 x down below. So, I'm actually going to get rid of one of the x's. Now, the thing is that we don't like radicals in the bottom of a fraction. Okay? I always make the joke that you don't want to have a party in the basement, no matter how rad it is. Anyway, so I need to multiply by the number 1 so that I can get rid of the fraction, or the radical down here. Okay? Because multiplying by 1 doesn't change the overall fraction. Okay? Multiplying by 1 keeps it exactly the same. So I'm multiplying by a number divided by itself, which is the same thing as 1, that will cause this square root to cancel out. So looking at this, I would normally, because this is a square root, has an index of 2, I would normally need a pair of 5's and a pair of y's. So I'm going to put another 5 and another y so that they pair up and would move outside of the radical. And so what that'll do is in the numerator upstairs, that would turn into a 5x squared y. And in the bottom, the 5's pair up and move out, and the y's pair up and move out. And so now I no longer have any square roots in the bottom, and I'm all done. The only step after this that might sometimes occur is if there was a number that was out here, it might cancel out down here. So you have to see if you can reduce it all. This one doesn't, so you're good. Let's do it again. So we're going to cancel out what we can, just to simplify it. So here there's 4 x's and 2 x's. And so that would leave an x squared in the numerator. And in terms of the y's, there's 1 y upstairs, 3 y's downstairs. So that means that the y cancels out and I'm left with a y squared. Got a little wild with my bars here. There we go. Okay, so I'm going to multiply by the number 1 so that it'll get rid of the radical down here. Now, this is an index of 2. I already have 2 y's. So I don't need to put any y down here because it's already going to move out of the radical. However, I need to get rid of the 2. So I'm going to multiply by the square root of 2 over the square root of 2. So in the numerator, 5 times 2 is 10. Now, there is an x squared up there now. Right? So when I canceled that out, that x squared turned into something that can move outside to the radical. So I moved him outside. And down below, the 2's pair up, so I get a 2. And the y's are paired up, so I get a y. And then I'm checking between the x and the 2y. If anything can be divided out, and nothing can, so I'm good. So one thing I want to point out, this isn't directly taught in this unit. I mean, it is if you have the Savas textbook and you're not at my school system, but my team decided to skip the adding and subtracting of radicals. But I need to point out that if you are adding and subtracting, to combine them, they have to have the same exact index in radicand. So like here, this would be 3 cube root of x. And this would be not possible on this one because they have the same index, but they don't have the same radicand. So you can't combine them because they're not like terms. Okay? And so what we're doing is we're talking about distribution here. Okay? You guys see distribution a lot. A lot of times, you saw this with GCF material, you saw it with factoring, stuff like that. Now we're just redistributing. And it works pretty much the same way as it always has. So when I do this, root 5 times 2 is just 2 root 5. That part's easy. But when I get to the 10 here, right, I have the 5 from the square root of 5. And the 10, color him red, why not? He breaks up into 5 times 2. And so this actually has an expression that I can bring out, which I need to do. Now, these have the same index. These both have an index of 2. But their radicand is different, so I can't combine these. Which means this is the final answer. Now on this one, right, I have a binomial times a binomial. So just depending on how you're comfortable, you could double distribute. With these, I like to use the box method. So I'm going to use the box method, but you live your life. If you prefer to double distribute, or some people call it foiling, go for it, man. Like, yeah, whatever works for you. Okay, so I'm going to go ahead and write these on the outsides of my box. And this just gets things like orderly for me, because I tend to lose terms because I get distracted really easily. Okay. So in our first box, 2 and 3 make 6. In our second box, 2 times 2 is 4, and then there's still the root 5 there. In our third box, 3 and 4 makes 12. You still have that root 5. Now on this other part, right, 2 times 4 is 8. And then I have the square root of 5 times 5, which is 5. So this turns into 8 times 5, which is 40. And so when I'm looking at combining my like terms, right, the 6 and the 40, they can combine. And then these have the same index and the same radicand in them. So these ones can actually combine also. Okay, so the 6 and the 40 turns into 46. And 4 root 5 and 12 root 5 is 16 root 5. And so that'll be our final answer. Now you have this idea, which we've seen before in this class, called conjugates. So conjugates are binomials that look the same, but one's a positive and one's a negative, right? You guys saw that a lot with the difference of squares, right? Remember the difference of squares formula looks like this. And oops, that should be a minus b. But anyway, you guys have seen this before. We also saw this with imaginary numbers. And we liked it with imaginary numbers because it made the imaginary number go away. We like it here with conjugates because it's going to make the radical go away. So conjugates are really useful because they get rid of radicals, which can sometimes be hard to do. Okay, so just multiplying out, right? I have a 4, I have a 2 root 3, I have a negative 2 root 3, and I have a negative root 3 times root 3, which is actually a negative 3. So when I go to combine, right, these guys are like terms, and these guys are like terms, but the things in the yellow, one's positive and one's negative, so they cancel out. So I just combine the 4 and the negative 3, and I get a 1. So we're using that idea of conjugates in order to rationalize the denominator here, where I have a binomial. All right, this is a pain in the tuchus. This part really sucks, and I know you're going to hate it. Okay, here's our procedure. This is what we're doing. We're going to multiply by the conjugate of the denominator, which, yeah, is going to require 2 boxes. Okay, then you're going to reduce the coefficients if possible. Okay, so this one, the conjugate of 1 minus root 5 is 1 plus root 5. So just like we were doing up above, I'm multiplying by the number 1 here. But this is a hot mess. Now, you can use the box if it helps you to use the box. Okay, I'm just going to double distribute and hope that you're following along. Okay, so I'm going to take this 3 and times it to each of these. Okay, so 3 times 1 is 3, and then I get a 3 root 5. Now I'm taking root 5 and timesing it to each of these. So 1 times root 5 is root 5, and root 5 times root 5 is 5. Now, down below, remember with the difference of squares formula, I'm going to times the 1's together, I'm going to times the root 5's together, and I'm going to call that good. Okay? Now, I'll go ahead and I'll write it out in freehand so that you could see what that looks like, where this term cancels out. Right there. Okay, so I multiplied through that 1 that was there, okay? So now I'm combining my like terms. So in terms of like terms, those guys are all technically like terms, although some are in the top and some are in the bottom, right? And these guys are all like terms. So up top, the 3 and 5 makes 8. And 3 root 5 and root 5 makes 4 root 5. Down below, 1 and negative 5 makes negative 4. And then the root 5's cancel. And then you need to reduce if possible. So I'm looking at all the numbers that are in front of the radicals, and I'm seeing if I could divide anything out. So the 8 and the 4 are both divisible by negative 4. So I'm going to distribute that negative 4 here. So 8 divided by negative 4 is negative 2. And negative 4 divided by 4 divided by negative 4 is negative 1. And there it is. Kind of ugly, but solved. Let's try it again. Okay. So again, I'm multiplying by the number 1. Now the conjugate to this bottom part would be 4 plus root 15. Okay. So up top, I'm multiplying the 6 to both of these. So I get 24 plus 6 root 15. And then I'm going to multiply the root 15 to both of these. So that turns into 4 root 15 and 15. Down below, I'm multiplying the 4 to both of these. So I get 16 plus 4 root 15. And then I'm going to multiply the negative root 15 to both of these. So I get negative 4 root 15 and negative 15. Be aware, you cannot cancel those out. That's not allowed because there's other addition and subtraction here. Okay? You can only cross out if it's multiplication. So I'm looking for my like terms, and I'm just adding a little color to them so I could see it easier. So these are my numbers without radicals. And here my radicals match, right? So those are all combinable with one another on their respective levels. So in the numerator, 24 and 15 gives me 39. And 6 root 15 and 4 root 15 makes 10 root 15. Down below, the pink stuff cancels out. And 16 minus 15 is 1. And so we can actually just get rid of that because dividing by 1 doesn't do anything. And there we have it. Now, in your notes, I left a special spot for you guys to add a note to yourself. That way, if there's something on this set of pages that, like, you feel like you need as extra notes to help yourself, I wanted you to have some space there in case you need it.